So for this question, it is asking what is the major product of this reaction? So by taking a look at the molecule and its reagents, it appears that this reaction is going to be an electrophilic aromatic substitution reaction, also known as EAS. By taking a look at the reagents, which is Br2 and FeBr3, this makes it a bromination reaction. Just as a reminder, we know that this reaction is an EAS because this exact molecule is aromatic. Alright, so we're going to start off by doing the mechanism. So for this reaction, we're going to have to form our electrophile. This is because Br2 in itself is not a good enough electrophile. So the first step in this mechanism would have to form the electrophile as mentioned before. So in order to do that, a bromine is going to attach to iron. So when this happens, you're going to leave one of your bromines positively charged. Meanwhile, the metal ion is going to be negatively charged. Before doing anything else, we would like to establish which substituents are electron donating groups and which ones are electron withdrawing groups. As we may remember, an oxygen with an R group attached is a strong electron donating group. Next, let's take a look at the ethyl group. As we may know, it is an electron donating group. However, it is not as strong. As we may know, electron donating groups are activating groups, meaning they activate the ring, therefore speeding the rate of the reaction. Electron donating groups are also ortho-para directors. So now let's take a look at the substituents. Let's start by doing the strong electron donating group. As we mentioned before, they like the ortho position, which is the second carbon to that group. So those two positions would be ortho. Now let's establish the para position, which would be the fourth carbon to that group, also known as the one that is directly down. That would be the para. Now let's take a look at the ethyl group. The carbons highlighted in yellow represent the ortho position because they are one carbon away from that group. And then the fourth carbon from that group is going to be the para. Disregard that yellow arrow that says para, that is incorrect, it is ortho. Alright, let's take a look at the ethyl group one more time. It appears for it to be slightly bulky. Now let's take a look at the possible positions in which we can place the new group. We can put it ortho or para. Usually the electron donating group is going to be the one that dictates if it's ortho or para. If we take a look at the ethyl group, we can see that it's slightly bulky and therefore its ortho positions are not going to be favorable. So therefore the para position is more favorable. If we place the new group in the middle of those two groups, it's going to be very unstable, as it's going to be very crowded there. So therefore, we should not place it there. And it is most likely not going to happen because it's going to be more difficult to even attach it there. Once we have done our electrophile, we notice that the bromine with the positively charged already has too many bonds. Therefore, in this reaction, we're going to attach the bromine at the end. So now that the bonds between the bromines are broken, we are now going to form our carbocation. So now since we have our resident stabilized carbocation form, we've also got to remember that our FeBr4 is also going to be present. I've also put brackets around the molecule just so just as a reminder that there are resonance structures associated with that, but in order to save time, we have avoided that today. Now for our base, the bromine has attacked that hydrogen and deprotonated, so that way it's going to be able to free up those electrons, re-establishing aromaticity. This gives us our product. We are also going to form FeBr3 and HBr as our byproducts. Now let's take a look at our question and our answers. So it appears that answer A is incorrect because the bromine will never be put into the ethyl group. Answer B is also incorrect, as we already established that the bromine being placed in the middle is going to cause instability. Answer D, when we look at the meta and ortho positions, we can see that the bromine was not placed there. Instead, it was placed in the meta position, which is incorrect because both groups are electron donating groups. Lastly, our answer C seems to be correct, as it is the same exact molecule we drew.